the next question. Okay, another very classical question that I can take a look at. Alright, so let's begin. Alright, so to the question, the force F acting on a conical pendulum depends on the mass m, the velocity v, and the radius r of the horizontal circle described. Derive an equation between F, M, V, and R using dimensional method or dimensional analysis. Okay, so we are going to use dimensional analysis to find the relation between the force acting on a conical pendulum with mass, with velocity, and then a radius that conical pendulum describes. Okay, alright, so the first thing to do is to write our physical quantities. So there is force, we have force F, there is mass M, there's velocity V, and there is radius R. Okay, alright, so the next thing to do is to find their dimensions. So force, dimensions of force, MLT minus 2. By now we are familiar with this. Mass is just M. Velocity is LT minus 1. Radius is L. The next thing is to write a proportional equation between them. So you know that F depends on M, V, and R. We don't know the relation between them, so I'm going to use constants. Okay, so F depends on M to the power A, let's say A, B, and C. Where A, B, and C are constants, we are going to be determined. Okay, so introducing the constant of proportionality, this now becomes K, where K is the constant of proportionality. K, F equals K, M to the power A, B to the power B, R to the power C. Right. So our aim again is to find A, B, and C. And if we're able to find the constant A, B, and C, we can clearly define the relation between F, M, V, and R. So let's begin. How do we do that? We're going to use dimensions. So by using the fact that the left-hand side, the dimension of the left-hand side of the equation should be equal to the dimension of the right-hand side of the equation, we can find A, B, and C. So for now, we can ignore the constant proportionality. Okay, the constant proportionality was just introduced to make us be able to write an equation here. But because it's a dimensionless constant, it can be ignored. Okay, so now that means that dimensions of F must be equal to the dimensions of M to the power E, dimensions of V to the power B, and then dimensions of R to the power C. So this is M LT minus 2 being equal to M to the power A multiplying LT minus 1 to the power B, and then L to the power C. If I expand this, I'm going to get M A L B T minus B L C. So M L T minus 2 equals M A L B plus C, and then T minus B. In terms of dimensions, I can just equate the exponent. So I can say that A equals 1. Can I say that? A 1. So now I found A. I can also say B, this is my equation 1. I can also say B plus C equals 1. So equation 2. I can also say B equals negative B, negative 2. And so my B is 2. So I can substitute B into this equation 2 to get C. So that will be 2 plus C equals 1. So C is equals 1 minus 2. So C is minus 1. So now I know A is 1, B is 2, and C is minus 1. So all I have to do is substitute into this equation, and voila, I have my equation. So F now equals k m to the power 1 v to the power 2 and then r negative 1. Another way of writing this is f is k equals mv squared over r. So the actual relationship is this, and what helps us to arrive at this correct relationship is dimensional analysis. It's quite simple. So here on the board is also another question, another very, very classical question that students come across a lot, okay, but it has a different twist. Okay, so let's see how we're going to solve a question like this. Okay, the question says that the force acting on a body of mass m moving along an arc of radius r is given by the equation, by this equation. Find the unit of v and I. Okay, so we are going to assume that we don't know what v and I is, but then we know what all the other physical quantities are. We know what f is, we know what m is, we know what r is, and we know what t is. Okay, but then we don't know what I is, we don't know what v is, and we are going to find the unit using a dimensional method. Okay, you can't just solve this question. Before you solve this question, you need to use some principles. Okay, some principles of dimensional analysis. And let me demonstrate this principle. For example, we already know one which we've used to solve previous questions. For example, if I have an equation like this, okay, I know that in dimensional analysis, if this equation is correct, then all the dimensions of the right hand side must be equal to the dimensions of the left hand side. Okay, but that's not the only principle that there is. There is another one. If this equation is correct, okay, in dimensional analysis, the dimension of each term should be equal. So the dimension of this term should be equal to the dimension of this term, and that should be equal to the dimensions of this term. What that also means is that the unit of each term should be equal. So the unit of a times t should be equal to the unit of u, and that should be equal to the unit of v. Is that okay? And that is what we are going to use to solve this question. So for a question like this, if I have f being equal to mv squared over r plus I over t, then first of all, I know that the dimensions of f should be equal to the dimensions of this term, and that should be equal to the dimensions of this term. I can find the dimension of this term. Okay, f is force, we were told in the question. So the dimensions of force will be m, l, t minus 2. So that should be equal to the dimensions of this whole term. Okay, so if you take that whole term, the dimensions of m times the dimensions of v squared over the dimensions of r should be equal to m, l, t minus 2. Mind you, we want to find the dimensions of v. Okay, and we know this, you can find the dimension. It has been defined for us in the question. M was defined as mass, so I can say this is m, capital dimensions of v squared over l, and this is equal to m, l, t minus 2. What I have to do is make v the subject, the dimensions of v the subject. If I do that correctly, I'll go to find the dimensions of v. Okay, so let's see how we are going to do that. This is going to be v squared being equal to m, l squared t minus 2 over m. So the dimension, if you do it correctly, this is what you arrive at. Okay, l goes here, and then m divides it. So simplifying, the dimensions of v squared will be equal to l squared t minus 2. And so the dimensions of v will be equal to l t minus 1. These are the dimensions of v, l t minus 1. How about I? How do we find the dimensions of I, or the unit of I? I'm going to use the same analogy. So the dimensions of this term, this whole term, have to be equal to the dimensions of f. So I think I have to clean my board a little bit. So the dimensions of f will have to be equal to the dimensions of I over the dimensions of t. So if I make the dimensions of I the subject, I'm going to get the dimensions of I being equals to the dimensions of f times the dimensions of t. So the dimensions of I is going to be equal to m l t minus 2 times t. So I'm going to have the dimensions of I being equal to m l t minus 1. So now I know the dimensions of I know the dimensions of L t minus 1. So I can infer the unit from their dimensions. So the unit of I will be kilogram for m, meter for length per second. The dimensions of V will be meters per second. So you see, this is the unit of I infer from their dimensions using dimension analysis. You can see I is impulse. That is why it is I. And this is the unit for impulse. Okay. And how do we arrive at this? We use dimension analysis. So dimension analysis proves very, very powerful. This might look simple because most of the units we are using, physical quantity we are seeing, we are already familiar with them. But in a case where you are given an entirely new equation which involves physical quantities that you've not seen before, you realize that this will prove very, very, very useful. Okay. And so you better appreciate the usefulness of the power of this simple tool. Okay, more in such cases than in simple cases like this. So it's really, really, really important. Don't forget to like, share, and leave your comment down below.